So Maggie was created on the fly using the new operator, and Lisa was a stack member. So
A local variable.
yeah, local variable. But yeah, this view giving you the ability to see the whole scope of the function. Like almost every time I enter a function, the first thing I do is I zoom out and I look for all the calls.
Yeah.
And then I start to focus in on the calls that are most interesting. And with the text view, you'd be just scrolling. Okay, so did everybody grab the dropped.exe out of the share?
Yes.
So if you haven't done that, go ahead. So drop.exe is what we'll call an incomplete program. And not only is it incomplete, but there's actually a flaw in it. Okay? And it's really, I mean, the goal here is to demonstrate how you would go about creating the structure definitions and recognizing classes in an executable. So go ahead and open up drop.exe in IDA. Just copy it over.
We're doing dropped, not dropped.
Dropped with a D at the end.
Not to be confused with that Windows one.
So I'll assume you're all with me here. So if we just go ahead and try running this, hit F9, and hit this break this software exception. As we did yesterday, we're just going to hit F9 to go past it, say yes, we want to pass the exception to the application. And this means we've hit another exception, so invalid handle. Okay. And we've ended up in somewhere in NTDLL. So that's pretty ugly.
Or that's not code.
Now, in debugger, tracing stack trace. Make this a desktop window. This will give us an idea of where things went wrong. So, see, start out in NTDLL up to kernel 32, then to our main CRT. So this was the C runtime stuff that I was talking about. Then we've got our main function, some function called by the main, and then we're back into some operating system.
Where's stack trace?
Okay, so stack trace is under debugger, tracing, and then it's right here, Control Alt S or stack trace. Okay. So stack trace allows us to go ahead and jump to the different locations currently in the code flow here. So so the first thing executed is on the bottom. The top thing here is the most recent thing executed. So that's where we are currently. Now you can resort the stuff, and then we start to lose that context that we had. So
can you get the sorting back?
What's that?
Can you get the sorting back?
Well, I do not believe you can without reopening it. So if we close it, go back to debugger, tracing, stack trace. So the sort options, unfortunately, are by address and by function, and neither of those are the order they were executed in. So, in fact, I actually didn't reorder it properly. Awesome. So don't sort them because you'll lose the whole context of the order they were executed in. But the two that are easier to find are going to be this sub D 81510 and our main functions. This one appeared. This one wasn't here before. Interesting. So we see this call to close handle. So I jump to that. I'm gonna put a breakpoint there, and I'm gonna come back to that. But for now, I'm gonna see. Just got this ugly thing. What are the calls to this? So using the graph overview allows us to go ahead and browse through the function, through the function to be able to kind of figure out what's going on in this application. We've just got all sorts of calls, and where to begin is totally up in the air. We do see right here we've got an operator. Operator new call. So we've got new creating some object of some sort here. It's 1C bytes. So that might be something worth exploring. We've got these messages about these strings here. This inherited.txt, inherited2.txt. And if we run this, you'll see right here in our temporary directory, and I told you you could get to that by browsing to %temp%. Sort this by modified.
Reclass.
Top one here. Where is it?
Reclass? RE class?
RE class, that's right. Okay, so in here we've got this inherited.txt. Not quite sure what the deal is with this inherited2.txt. But what functions should you expect to see in here? Create file.
Right file.
Yeah, definitely the create, right, close file.
Anything that has file in it.
So we've got write file and close file. We also created a directory somehow.
So whatever Windows function does that.
Right. And this, I would close a process. So basically, this is an incomplete set of classes, okay? And where functions weren't completed, they essentially it's got some sort of message to indicate what it does, or maybe for some reason we didn't want to implement this function, but it is going to be called for some reason because it was less complicated to call the function than to try to find a way to prevent it from being called. So then you would potentially say, alert the user, okay, we don't allow this behavior. So in this case, you can assume that there's some sort of close function, and here it wasn't actually created, or it wasn't actually necessary for some reason. So what I'd like you to do is take a look at this guy, try to identify a some sort of a class structure. And I'm going to show you a call to a method. So Willie was asking about what these calls look like. So first of all, we've got this. We've got some operator new. We get this new object stored EAX. We'll call it some object of size 1C. Okay. And you can write something much more concise than I did. I'm just being very verbose. Okay. So this call uses this guy right here. So what are we doing here?
Constructor?
Okay, this is the constructor, and we're giving it the object, and ECX is going to be treated as ECX is going to be used to get this pointer. So if I step into this function D81270, assuming that we're talking the same base address, you'll see when we enter the function, we push ECX, and then we store it into var4. So what are we going to call var4?
This.
This. Thank you, Willie. And we got a subsequent call here. It's doing some sort of output. So I'm going to step back to the main. So that's what it looks like when a function is so that function is not inherited. That's just a function that comes with all those objects. All right. So the virtual function table is only going to occur when you have to override the function. So right here, we've got this call to EAX. All right, and we work backwards. EAX is coming out of some array. And that array is coming out of EAX somewhere. Keep working our way back up here. We get up to this var4, which comes from var2AO, and that's returned from our constructor here. So this is initialized, some sort of initialized object. Okay. And I'm going to call this guy here, where we store our initialized object into the address of our initialized object into object pointer right here. It was originally called var4. We move it into EAX. We get the first item, so we know the first item is in the structure is a B table, okay? Because we get its value, then we get some value within that table, and then we call it, okay? So that tells us that we've got some sort of a function table. So in my structures, using Shift F9, at this point I have no idea what this is. So I'm just going to call it object type. And I'm going to insert a D word by pressing D 3 times. that B table. Okay. So now what you're going to have to figure out is what is that? What is this function? So take a look in the constructor here. Try to trace that back. What actually gets stored into that table at offset 8? Okay. And I'm putting a comment here that this is so edx plus 8 is the third function in the V table. Okay. And I say that because 0 would be the first one, edx plus 4 would be the second one, and edx plus 8 is going to be the third one. Okay. So this is what a call looks like when you have an inherited function, an overridden function. Okay. So this was that situation where I showed you before the writer writes a book. Okay, there'd be some sort of call like this in that program. So I'm going to let you guys until the end of the day here. I'm probably going to wrap things up around 4. So I'll be around here until 4, maybe a little after that. So any questions you have, let me know. I will, as you guys figure things out, I'll talk about what you found and see if we can figure out what classes make up this application.
The structure window's all out of whack. It doesn't let me show the top of it for some reason.
Help you out. So, I mean, at this point, we've run the thing. You guys have any idea what sort of classes we're dealing with here?
No.
All right, I'm going to go with that.
Okay. Okay. So we've got some sort of file activity and we've got some sort of process activity supposedly. So keep that in mind. I'm providing you guys with a little script. Okay. So this is IDC. I had mentioned it earlier and I said we wouldn't do anything with it, but I realized this could really come in handy. Okay. Reason being, I came into this constructor and I saw that there was an object member at offset 18 hex. Okay. So that's 24, right? 24 bytes in. It looks like 4 bytes. We're storing 1 into this D-word pointer. So I'm assuming it's 4 bytes. I don't have anything defined beyond the V table, which we defined together. Okay, so this would mean I would have to go through this tedious process of making this big enough until I finally got to 18 bytes. Okay, very tedious. So rather than doing that, I can use IDC. Okay. This file is actually in the VA public folder under our room share, and what we've got here is got a bunch of variables. Okay, we've got type name. So type name is going to correspond to the name of the structure right here. that we defined, okay? We've got member name. This is going to be whatever the member is. So if it's, you know, a file length, then we can call it length, you know, something like that. We've got member size here. That's going to be, so if it's a 4-byte member, or you don't know what size it is, you can always start out with 4 bytes, and then you can modify it after it's in your structure already. And then there's the member type. So if you're unsure of these 2 items here, then go ahead and just stick with these, and then you can modify them once they're in your your structures window here. The last thing is the offset. So I just said this is what interested me. It's at offset hex 18. So I've given you this script which you can apply to this particular structure definition. So you can go ahead and run this, and then you can modify it as you see fit. So all you need to do is modify these guys right here. This code gets the structure by the name, so it's using our name object type. It's getting an ID for it. I print this out because I figured you might be curious as to how you can actually print something. When I print, you can see right down here. See how I've got all these negative numbers here? That's when my script printed out this ID. In fact, if I put a /n, it would look a lot cleaner. It's using standard format strings, and if you have any questions about that, feel free to ask me. And then the last thing it does is it actually adds the member to the structure using all the information we created up here. Okay, so any questions about that?
It seems too hard. It says there's no function defined. What does it say? Function declaration is expected in line 1.
Okay, so you actually ran it. You ran it as a file, right? So I didn't actually create. I didn't create a function. So I was just going to demonstrate using this through the IDC command.
Oh, I see.
So if you click on IDC command here,
Much better.
you can paste this code into this window here, and you can make whatever modifications you need. In fact, after you run it once successfully, if it fails, it's not going to stay there. But if you run it successfully, it will remain in here every time you open up that IDC command. So I'll go back here and click File, IDC command. I already have this in here because I ran it once, but I'm going to paste it again because I made a slight change. I click OK. And you can see I've got, it just helped with that ID. But if you look in my structures, now I have this member 18H, which is what I used here in our script. Okay. So if there are any questions about that, let me know. Otherwise, let you get back to it.
I have a C++ question.
Mm-hmm.
Never really used C++. What is a pure virtual function as opposed to a not pure virtual function?
Okay, pure virtual function is basically you're saying that the function has to be overridden.
If
Okay.
it's pure, it must be overridden?
Right. So this
Okay.
is a function that must exist. So you are definitely calling this in your program, and if the child class doesn't define it, then things are going to break. So the compiler won't even let that happen. So when you try to compile a child class and it hasn't overridden the pure virtual function of the parent, it's not going to compile.
So this is sort of, so it's sort of like an abstract function or an abstract class as
It
well?
creates an abstract class. So the parent becomes an abstract class when you use pure virtual functions.
Okay.
So you can't actually declare a member.
You wouldn't even be able to create objects of that type. It has to be a child.
You can't have an object of an abstract class.
Okay, thank you.
So basically, if you create the person class and you create this work function for it and you say it has to be overridden, this is called pure virtual function, then that means person, you can't create just a person. You have to create a new class, like, let's say we're creating a game and you want a warrior or whatever, then you would create a warrior class and he would have to override that work or fight function or whatever it is that you define in that parent class. Now, that's not to say that all functions within an abstract class can't actually do something. So you can actually write the code in the parent class, but as soon as you write one pure virtual function, you can no longer use that class. Did anybody figure out how the vtable is actually stored into our objects? So I've got this constructor up here, and so this is the constructor I was mentioning earlier that when I was doing my little walkthrough, I gone into here, and right here you have this pointer. It's moving the ECX, and then we take this offset here, and we store that at the very first item in ECX. So at the base address of this new object, we're going to store that address. Well, what's located at that address? A bunch of pointers. Okay, and we might assume that the boundaries, the end of this table is right here because there's no other offset defined here. So it looks like there are 5 different functions. Now, that's something that you're going to have to figure out as you look at this. But let's just take a look at the first function in this table. And use my overview. I've got create file. Okay. So that might help you out to figure out what that particular class object is. Yeah, biggest tip off that this was C++ to begin with. Other than information in the headers, you're going to see this constructor here, and it has virtual function tables. That's one of your indicators that this thing was probably compiled using C++ and written in C++. So just to be clear, you should have more than one structure definition. Okay. So be careful that you're not looking at struct member access and assigning them all to the same structure. Make sure that you're working within the context of a particular object before you make changes to your structure definition. So when I was showing you this virtual table, that was kind of an indication that you might want to start looking there to define this particular object. So I'll take you back to where I started. So I'm at this call to D81270. It's right in the middle. Yeah.
Oh, I'll scratch.
Oh. No problem. So we've got this big block at the top, then we've got this little one, we've got a bigger one, and then we've got this branch. So the left side of the first branch, this is where I'm trying to figure out what is this constructor, okay? So I dive into that. I've already determined there's a member at offset 18. And the size of this thing is 1C, so that is the last member of the structure. So now I've got this ECX is now getting the virtual table pointer, okay, at this instruction here. And now you have 5 functions, and technically 4 functions, because this is some null address. So this is actually signifying the end of the table. So you have 4 functions here to use to figure out what is this object. Okay? So then you can drill into one of these functions, and you'll see, just like in any other member function, ECX is moved into 10C. It's going to be our this pointer. And then you can figure out where are all the offsets to this. So highlight this. We've got one at 8. We've got one at 4. We've got one at 18 again, which we've already seen. And so on. So a handy thing you can do is you can actually apply struct offsets all across a block like this. If you select something and hit T, so as opposed to getting that little window with a bunch of just a list of options, you now get this more complicated guy here. And so we've got object type, and we see this X next to it. So what it's saying is it doesn't think that over this selection we could apply this object type. Now let's say we just focus on one register. What this is saying is anywhere I see some offset from ECX, I'm going to apply one of these object type members to our disassembly here. So I'm just going to go ahead and say, okay, I'm going to say, I think ECX is used as our this pointer, and it's of type object type. And you'll see it's going to apply this information here on our right to our assembly. Now let's see if that actually makes sense. Right here we move this into ECX. We've got this ECX plus object type plus 4. So this is whatever is at the offset 4. That could be right. So now if I come to my structure definition, define a member at 4. Go back to my disassembly. Now you'll see it's transformed into ECX plus object type field 4. So it looks a little clearer now. Here once again you see ECX used with object number 18, and so on. So I was quickly able to apply that object to the entire function. Now, some cases it might be wrong. You might find out that ECX didn't actually it didn't get this before we accessed the member, so it might be some other object type. But in this case, we see every time we see ECX plus some offset, it actually is used right after ECX gets this point. Okay. So right here, we can actually figure out what one of the object's members are. We've got create file A. This returns a handle to a file. Okay, it's moved into EAX, and that is stored into object type plus OC. So at offset C,
What key you press to put the field C in there?
I clicked on sorry about that. I click on address C within the object, or offset C. Okay. And I press D 3 times. D as in dog, delta. Okay, and I click on field C and I name it file. Now, that's actually too verbose because maybe this is part of a base class, and maybe handle is available to all the classes, all the parent class or whatever. But I can call my object type file type. That's a theory, of course. But I've seen that one of its main members is a file handle. So now I've got this object type. I've renamed it to file type. I've created a handle, and here we have it. So now there's another member at offset 10, and another one at 4 we can figure out. So pick one of them, and so start with field 4, try to figure out where it's used, and then that might give you some idea of what this actually is going to do for us. What member of the file type object this is. So using MSDN is definitely handy in this situation. Understanding what the different arguments we passed to IDA here. Let's see here. Okay. So one thing you can do with IDA is you can actually apply standard symbolic constants to your disassembly. So right here we see create file takes all these arguments, the third one being share mode. Now let's say I don't understand share mode, I want to understand what it is. I scroll down to where I see DW share mode in my definition here, and it tells me that there are these different constant values that one is for file share delete, one's for read, one's for write. So I can use create file to not only create a file that I want to write, but maybe I just want to read the file. Okay, and actually the share mode actually says when I open this file, I'll allow other applications to do this. So I'll allow them to read, delete, write. So chances are if you're going to write to a file, you don't want to provide file share write. Because then you're saying, I can write to the file at the same time while somebody else writes to it. Usually you want to have exclusive write access. Okay. So here I can apply what share mode we're using. I right click. I know it's prefixed by file share, okay? I'm going to right click this one, use standard symbolic constant, and then I'm going to type file underscore share. You can see that 1 is actually for read access. And now IDA, instead of showing me a 1 here, shows me that this is file share read.
Can you go through that one more? I wasn't in the right place.
No problem. Okay, so I right-clicked the 1
Next to the DW share mode.
Yep. Next to DW share mode.
What function?
You want to know what function I'm in?
Yeah.
I'm in D8 1540.
Except it's going to be different.
Just look at the last 4 digits.
Probably 1540 is probably.
Yeah, I'm looking at all that.
could also use your functions window and look for 1540.
Oh, okay. There we go.
Import.
Got it.
Okay, and then right-click the 1.
Yep.
Symbolic constant. And I already have this here because I've used it once, but you'll just click on Use Standard Symbolic Constant. And then file_share was the prefix. Just type that in, you don't have to do caps. Lowercase is fine. And you just click on that, click OK or double click, and there you have it. We've got, so in this particular function table, virtual function table, we've got call to create, okay? And it, for some reason, gets its creation disposition, which is determining whether we're opening the file, creating it. Do we create it always? Do we create it only if it doesn't exist? That is passed in using member 18. All right. Now there's another call here. Creation disposition is 3. Okay. And if we look at MSDN, that says open existent. Okay. So I'm going to apply this symbolic constant. So as I showed you before, I right-clicked the item, number 3, symbolic constant, use standard symbolic constant, open existing. So now I can call this function what?
Open file.
Open file. So for now, I'll call it open. Okay. Zeno is just pointing out that you can rebase things. I would not recommend doing this right now, because I'd hate to see you lose all your info, but I'm going to save mine. And under the edit menu, so what we were running into before was Reed had a different address than I had here, so he wasn't in 00D8 base address. Okay, he had something else. So I can choose to rebase. Go to edit menu, segments, and I'll rebase the program. And a fairly common base, and it's showing that, so my current is actually D81000. I'm going to change this to 401000. And at first glance, it doesn't look like I lost a whole lot. That's how you can change the base. Thank you, Zeno. So has anybody been able to somewhat identify what sort of objects we're dealing with here? Has anybody named any of the functions in the function tables.
Well, that.
Yeah, name the function table.
What's that?
Need to name the function table.
Right.
Looks like they've got, what, there's a base class. It looks like it has 2 descendants.
Okay.
Grandparent, parent, and child. It looks like the parent creates directories and the child creates files.
Okay.
I'm not sure that they're actually related. That's just speculation.
They are related,
They might be siblings.
but they're siblings.
Siblings. Okay,
Right.
that makes more sense.
So
And there's
here,
another class, just for processes.
right. So, and what you should find is there's actually shared code between all of them.
They all seem to share the close file handle.
That's correct. The close handle function is shared
Sorry,
between
close
all
file
of them.
handle, just close. Let's change it.
So, and that's actually not exhibited in our tables here, right? That's because the close handle function is actually
Well, it is in the tables, but it also gets called directly.
gets called directly for the process object, right? So, anyways, when I started in the virtual function table, we had this create function. Okay. Create file A, and if you dig a little deeper, you're going to find out that creation disposition is going to be for creation. And we've got, so we'll call it create, and we've got open, which creates using the open existing creation disposition. So if we look at this next virtual function table right here, take a look at this guy. This actually does a create directory, okay? And so we're seeing that's similar right there.
Yeah, there's a couple functions that just do nothing essentially, just return 0.
This function here, yeah, not really a whole lot going on here. We're setting things up. We're creating a this pointer, and then we just return 0.
So that's just so that the class is no longer abstract. It's just simple, concrete implementation.
Right. Well, this probably means that it's not implemented.
Is there some reason the compiler doesn't just optimize that function out? There's no point in even calling it.
Right. I guess that depends on the optimization settings, right?
Okay.
So in my case, I didn't actually use optimizations because
Okay, that makes sense then.
that creates uglier code.
Oh yeah, definitely. No, it just seems weird that optimizing a compiler would leave that in.
So what you'll see here is both of these virtual function tables have this same function in them, okay? And it's the function that actually closes the handle. So, in all likelihood, these are probably 2 classes that are related to each other. One a directory class and one a file class. And let's say close handle. And so they share this close handle function. If we actually look at that code, see if I can bring this up for you. I actually have the system class here. Okay. Data class and file class. So file and directory class, these both derive from
From that 180 offset.
Right.
So what does it mean? Does the pure call, does the fact that the virtual function table for the 180 offset type mean that it's totally abstract? Because those are both pure. It has two, it looks like its virtual function table has two items in it.
Yeah.
The one under it, and they're both pure call, which I looked up, it seems to mean that it's a pure virtual function.
Right.
So my understanding was that means that it needs to be implemented, so this must be an abstract parent of some other class.
That's,
Unless there's something else going on.
That's the abstract base class. That's, although,
right, so just as you said, yes. So this is going to be the default class, or the abstract class. So you can see right here, directory and file, neither of them actually define the close function, which is actually defined up above here. So you can see system class, we've got create, open, and close, and then this class member function, or this is a class member function. So this is actually what you were seeing right here. Read?
Yes.
So this is the abstract class that you were looking at. So, all right.
Whoa. All right. Huh.
And you can see close is defined by data class. So that's shared by data class, and then so that's why in this situation here you see close handle is the same function for both
Right.
directory and
related.
file. Okay. So I will. I can actually provide code to you guys, the source code for this. Obviously, I don't want to give it to you beforehand, but what I will do is, we've got the roster. Maybe I'll have Zeno send out an email with maybe something like a transfer folder location or something like that, and then we can get the source code out to you guys, so you can kind of look at these executables and compare what the source code looks like and what you're actually seeing in the assembly. Okay. So that pretty much brings us to an end here. I'd be happy to answer any questions that you have, and if you want to continue working on this particular example or any other ones and have any questions, you've got my email address. It's in the course materials. So any questions before we wrap things up here? I'm sorry?
Does either give any way of like patching an existing binary? So
Yes. So actually, with IDC, you can patch bytes, dwords, and you can do that within a loop. So if you in the help menu, you got this help index, and
but the only way to change memory is through IDC.
what's that?
The only way to change anything is using IDC.
That's-
There's nothing on the UI.
That's right. So you can change registers as you're debugging through the UI in the general registers
Right.
window,
But you can't change memory.
but you can't change memory. So in the help dialog box here, if you search for IDC, you've got all different sort of options here, but really what we want to get to this IDC language and index of IDC functions. And this is this just defines all the different functions. Quite frankly, it's not very well laid out. It just everything listed in alphabetical order, so finding any particular thing you're looking for can be difficult. In newer versions of IDA, a lot of people tend to use the IDA Python libraries, and there's some pretty decent documentation for that online. It's not the greatest. Sometimes I actually have to come back to here when I find IDA Python function, and it's not defined on the website online. So I end up coming to here, and then it fills in the gap for me what parameters I'm supposed to pass to it. But all of these functions, or at least most of these functions, are available in the IDA Python. So, but yeah, if you have any questions about is there a function to do a particular thing in IDA, ask Zeno or me. Or, well, I guess I'm signing Zeno up for something he hasn't offered his name up for, but I'm sure he'd love to answer your questions.
Because you already see already. He's recusing himself.
All right, there you go. He says he's useless to you. I think he's just being humble. There you go. Ask him anyways. All right.
Of course, the patching mechanism in IDC is pretty ugly.
But I mean, you could probably
Word,
figure out exactly
keyword.
what it is you want to patch and then do it with a different program.
Yeah, you can
Right.
do it with a different program, but sometimes you want to do it. Maybe there's some sort of encryption routine. That's the most frequent usage I've had of the patch bytes. But that is all.
It's also nice when you're just going through like cuts of memory sometimes.
What's that?
Have you ever used the decompiler in IDA?
I have used the decompiler. I especially enjoyed using it when I was looking at driver code because I am not a driver developer, and I've definitely come across drivers in my experience. It's not perfect, so first of all, you can't ever get the original code back unless symbols are available to you, because when a compiler compiles an application, it's going to throw out symbol information, so any names of variables. That's why when you see a function in IDA, you see bar4 and arg0 and all this stuff. So even when you're looking at the pseudocode and the it's called the hex raised decompiler, you're going to be missing information, but it very often gives you readable pseudocode, C-like code. In fact, you can actually produce C files with it. So it's expensive. It's not cheap. It's not cheap. It's actually much more expensive than IDA itself. But if you do this stuff on a regular basis, and if you're trying to restore code for, like, you lost the source code for some program and you want to restore it, it could come in handy. So, especially if you have symbols.
Cool, thanks.
Any other questions? All right. Well, thank you guys for hanging around this long, and you are free to do what you want.